Hello everyone, welcome back to Ampnics. In this video, we are going to discuss something really exciting. So from last couple of days, Grok AI is in the news. And nowadays, everyone is using AI tools in their daily life tasks. I wonder, can we electronics engineers also use these tools for designing hardware or writing the firmware or developing a product? So the answer is not pretty straightforward. In this video, we are going to design a air quality monitoring system's hardware using AI tool, and we will see how we can utilize the potential of AI tools. So let's get started. You can follow us over Twitter also, which is formerly known as X. So we will open Grok. So for using Grok, you need a Twitter account. The user interface of Grok is quite similar like other AI tools. We will start asking our question. So I have already written my questions here. What I will do, copy it, paste here. The prompt is, I want to design a standalone IoT-based air quality monitoring system. Guide me to develop it. So here's the description. Designing a standalone IoT-based air quality monitoring system is exciting project. Exactly, it is an exciting project. Let's see requirements. So parameter to monitor. Common air quality matrices includes PM2.5, PM10, particulate matters, CO2, CO, VOCs, temperature and humidity. Well, temperature and humidity in this project we are keeping it optional, and we are concerned about carbon dioxide or CO2. Okay, and for standalone, it should be operate independently with own power source, battery plus solar. That's perfect answer. That's 100% perfect. And for connectivity, use Wi-Fi, LoRa or cellular. Exactly, we can use Wi-Fi, LoRa or 4G, 5G. Okay. Data output, real-time monitoring, data sent, cloud platform, display. Yes, that's 100%. Then for environment, indoor, outdoor or both. So the requirement is 100% correct. This is like this is like crazy. It is 100% correct. So we can determine the application of our project. So as of now, we will concerned about CO2, and we are going to use Wi-Fi, and we will use a OLED display. Okay, and environment is going to be both. We will use it inside and outside. Select the hardware components. Step 2. So hardware selection is there, and we will use ESP32 or ESP8266. Well, it is suggesting you can use any of them. So affordable Wi-Fi enabled, widely supported by ESP32 is more powerful and versatile. Exactly. ESP32 is way more better than ESP8266. Well, this project is quite simple, so we will use ESP8266. But it is suggesting both of them. Then for sensor, it is suggesting us PMS5003 or PMS7003. So we are not going to use this one. And for power supply, lithium ion battery 18650 with TP4056 charging module, and optional smaller solar panel for recharging. Actually, this is great suggestion. Then we have a display, OLED display. It is optional, but we will use definitely for monitoring it on real time. Okay, so we will use this enclosure. Okay, IP65 rated. As you can see, like it is suggesting us the most of the component, but still there are few components are missing. So for that reason, you cannot rely on AI tools 100%. But if you have little bit foundation on electronics, then you can use 100% AI tools with the full potential. Okay, then for hardware assembly, it is saying the pins and all. Then for software setup, it is giving us the code also. Okay, then cloud integration, whatever the cloud you will use, this is not the our part. We are only interested in designing the hardware at this point. In this video, we are only concerned about the hardware. Okay, so now I will specify the components also so that it can give us proper information. Because in this prompt, if you notice that this is like very general question. Okay, I want to design a standalone IoT based air quality monitoring system. If you see here, like I didn't specify anything here. So now I will specify the components, then we will ask it again. I have written another prompt for here, and I will copy this, Control plus C, and I will paste it here, and I will add another device which is our OLED display. OLED display. Okay. So what's this prompt? I want to design it with the following components. So we are going to use this ESP8266, CS340C, MT3608, MQ135, AMS 1117, TP4056 battery OLED display. Provide proper block diagram and data sheets too. Okay. So the system overview is here. Use MQ135 sensor to measure the quality, air quality. So we are concerned about CO2 as I said earlier. So ESP8266 as a microcontroller and display for real-time monitoring. Battery TP4056 for charging it, MT3608 for boosting the voltage, and I will explain further why I need it. Okay, I will explain in the schematic design. MS 1117, okay, CH340C for USB to serial program. Okay, so if I see here the block diagram, so basically we have our battery here, then that battery is connected with the TP4056 charger. Okay, basically it is responsible for managing the battery. Okay, then we have boost module, then that boost module is connected with the MS 1117 MQ135 sensor, ESP8266 OLED display, and we have CH340C USB to serial. So the block diagram is correct. We will follow this block diagram only, and here's the explanation. Well, I'm not interested in this explanation, you can check it. Okay, and we have hardware conditions also. So we can see like connect the battery with the TP4056, which is correct. Then we have analog output of MQ135. We have to connect it A0 exactly. In ESP8266 we have only one analog pin, which is A0, so we will follow that one only. Okay, so as you can see, like you can still use the AI tools for gathering the knowledge about components and for hardware connections. But I will always suggest you, so you can match your schematic design or your requirement or your layout design with the datasheet also. Do not rely on AI tool 100%. Okay, so what I will do now, I will follow this block diagram and I will design the schematic. Here we have our schematic design. All the components are differentiated according to their functionality. In this, we have USB to UART convert. So this CH340C is responsible for converting the data of USB into UART because our microcontroller supports UART communication. So mainly this is responsible for programming and debugging. Additionally, this USB section is also responsible for charging the battery. Okay, this TP4056 is connected with the USB. Okay, so this is USB to UART converter for programming and debugging, and this USB is responsible for providing the energy into controller and battery. Then further we have a power supply section. So in power supply we have a boost converter and LDU. Why we need boost converter? Because it is a standalone device, and the primary energy provider in this hardware is battery, and we are going to use a LiPo battery or Leon battery, which is about 3.7 volt. And we know that our gas sensor MQ135 works on 5 volt. So for that reason we need a boost converter. We have to boost the voltage of battery up to 5 volt. Then we have a voltage regulator or LDO, low dropout output voltage regulator. So mainly this is responsible for converting the 5 volt into 3.3 volt because microcontroller works on 3.3 volt. Then we have a battery section. So this battery section, basically I have connected here a JST connector and a switch. So with the help of JST connector we will plug in the battery. Then we have a OLED display which is working on I2C protocol. So we have connected here SDA and SCL, and there's no need to add additional pull-up resistor. Okay. Then we have battery charging section with TP4056, and we have gas sensor here. This gas sensor is providing us analog value which is connected with the analog pin of our microcontroller. We have here a LED which is for future use, and you can utilize it for debugging also. It is up to you. Then we have some passive components also such as capacitors. And there's one more thing which I want to show you here. This R11 0 ohm resistor. So this 0 ohm resistor is very useful in hardware debugging. If your PCB failed or get any error, you can use this 0 ohm resistor a lot in your hardware. So it makes the life easier of hardware developers. So it is always good practice to use 0 ohm resistors, whether if you want to measure the current or if you want to check the circuit like it is working or not. This 0 ohm resistor helps a lot. Basically what I did here, I connected this 3.3 volt net into another net which is MCU underscore 3.3 volt. So if I remove this resistor, you cannot power the further devices. Okay. So in this way this isolation works. If you want to copy exact schematic, you can check the description. Each and every file which is associated with this project is uploaded over GitHub. You can directly download it from there. And more for most of the blocks I followed the datasheet, and you can match with datasheet also. All right. Sometimes it happens that some developers or some engineers makes mistake, or sometimes they use their own brain, or sometimes people customize also. If you see here in gas sensor area, in datasheet you will follow one resistor, while I used here two resistors. So this is for my own convenience. And you can manipulate the value also, like if I am not getting the proper value, I can change the value of resistors. So this is for your own convenience. Once you start doing the project, slowly you will get to know about more. And if you don't know how to design the schematic or how to design the PCBs in KiCAD, you can check the description. I have attached a playlist link, how to KiCAD. In that playlist I have explained the things within 2 to 3 minutes of videos. How to design the schematic, or how to design the layout, how to design the tracks. Everything is available in that playlist, so you can check that. Schematic is completed, we will again open Grok AI, and in further it is also telling us about hardware connections, so which I discussed in design about SDA, SCL, analog. Okay, then again it is providing us a Arduino sketch also, so that we can use this sketch to write the program. Okay, then datasheet links here, so you can check the datasheet also of each and every component. All right. Then after completion of schematic, we have to go for layout designing. So for layout designing, I will again take the help of Grok So I will paste my another prompt here. So in this prompt for layout designing in this project, I'm considering zero point 0.2 mm, 0.3 mm, zero point 0.5 mm and 1 mm of tracks. So zero point 0.2 mm is for USB data, zero point 0.3 mm is for other signals like passive component is used, which is for the passive component which is used in the PCB. 0.5 mm is for sensor power, 1 mm is for boost converter. So here I'm talking about the track sizes. Okay, so I will ask, is it good? Is it good for DIY project? Consideration of our track widths, current carrying capacity. So it is also telling us about the more detailed and like technically more for overheating or failing. This depends on copper thickness, typically 1 OZ and 35 micrometers. For standard DIY project, trace length, allowable temperature degrees Celsius, voltage drop, signal integrity, die fabrication. Anyways, we will go into detail about the sizes. So USB 0.2 mm connects CH340C with data plus and data line minus lines. So yes, zero point 0.2 mm is sufficient electrically, but risky for die fabrication. Consider 2.5, 2.5 or 3. Well, 3 point is not possible on our board, but I have already tested. So zero point 0.2 is also fine for me. But if you have different types of connector, you can use this also. But for this, I will stick with my own, is about zero point 0.2. Okay, it is up to you. If you want to follow the Grok's suggestion, you can follow that also. Your PCB will work fine. Then we have zero point 0.3 mm, yes, which we used for data lines and the passive component. Then we have zero point 0.5 mm. Okay, then we have boost converter. Okay, so it is agreeing on everything except like here it is saying that for sensor power it is suggesting us to 0.8 mm. Well, our PCB is not 10 centimeter, and it is suggesting that you can go with 0.5 mm. So I can say like whatever the data I suggested here, that's completely fine. We can go with this only. So as you can see, a double layer PCB is here. So you can see here we have 4 different size of tracks. Okay, so the different size of tracks is used for different purpose. The 2 mm tracks is for USB, and zero point 0.3 is for connecting the uh, devices such as passive devices or this transistor, resistor, network. Okay, and zero point 0.5 is for providing the energy into the providing the power into the sensor or our TP RTP4056. Okay, and for LDO or for boost converter we have used 1 mm of tracks. After completion of schematic and layout design, let's upload the screenshot of this PCB in Grok AI, and we will ask about the aesthetic, and we will tell Grok to rate this PCB on a scale of 10, and you guys can also rate this PCB on a scale of 10 in comment section. We will upload it. So from here you can upload the images, or you can upload the documents also. Okay, it is saying about the evaluation criteria. It is basically telling us some certain parameters to consider. So ESP8266, no visible decoupling capacitor near the ESP8266. No, it's not like that. We have the decoupling capacitor here. This is the decoupling capacitor. Well, it is showing us that no decoupling capacitor. Okay. Okay, so it is basically telling us about in proper detail manner. So we will check it one by one. Connection USB port U7 connects to H340C. MQ135 is connected via header, likely to be an clock pin. Power distributing elements. Well, it is not missing. It is available on the circuit. No pull-up resistor require. Yeah, because we already have it in our module, so there's no need of this. Then we have, okay, so here Grok has cutted our number, which is considerable. As of now, it is considerable. That's not a big deal. Then traces are moved straight to minimal vias. Actually, the color of PCB is black, that's why it is not visible. So we have poured the ground plane on the PCB. So I don't think so. The number it is detecting from overall is number is not considerable. Okay, yes, this is concerning. The thermal management is like MT3608 and TP4056. This is something which is considerable. So anyways, you can check this one. I will attach this chat in the description box. Also, you can check it by yourself. But the overall rating is about 7.5, which is like 8.5, because we have already as I said that we already poured the ground. Okay, so 7.5, or you can consider 8.5 also, which is considerable. 7.5 or 8.5 is considerable. Well, you can try your design and upload it in Grok and ask it about your result. Okay, so in this way you guys seen that how we can design the hardwares using AI tools. This was the video on hardware design using AI tools. I hope you found it helpful. If you found this video helpful, make sure to like it and subscribe the channel for more electronics related content.